Hello everybody. So in this video, let us learn how we can perform auto-scaling of Azure Functions using KEDA. Before we start, a bit of introduction about me. My name is Swaminathan Vetri. I work as an architect at Maersk. I'm also a Microsoft MVP under Developer Technologies for the past 4 years. I tweet at @SV Swaminathan, and I also have a technical blog which is available at swaminathanvetri.in. So the agenda for this particular talk, the video, is how we can create a new Azure Functions with service bus triggers, and then we'll learn how we can debug and deploy the Azure Functions locally. Then we'll go ahead and Dockerize that same Azure Functions and deploy it into the Kubernetes cluster, and finally we will learn what is KEDA and how KEDA helps us in auto-scaling the Azure Functions. KEDA is nothing but Kubernetes based event driven autoscaling. So if you want to follow along me in this video, you need to install a specific set of tools, so which is what I've listed down here. So the primary code editor what we would use is Visual Studio Code. So Visual Studio Code has a lot of extensions. So the extensions which are of interest for this particular session is on the Azure Tools extension, and you also need to have an Azure subscription so that you would be able to create a service bus on the Azure portal. And you need to have Docker Desktop either installed on your Mac or on Windows machine, and ensure you have enabled the Kubernetes cluster which is available into that. Or you can also install a Minikube if you want to use that as a local Kubernetes cluster. And the last thing is I've used Ubuntu with WSL to show some of the commands in the end. So that's more of optional. So that is not really mandatory to follow through all the other things. Okay, with that, let's get started. So what I'm going to do is I've already signed into my Azure here. So it is already pulling up all my existing Azure functions. So what you could do is just go ahead and create a new function. I'm going to create a new project. So I will be using C# as a language. And then what we would do in here is using a service bus queue trigger. These are the different other triggers what are available for Azure Functions. So in this example, basically we will have a service bus queue trigger. That means the function will get triggered as and when a new message arrives in the service bus. So we will post a message in service bus and see how the function is able to retrieve that message. And in the end, what we would end up seeing is how do we scale these messages? How do we scale this Azure function when more number of messages are present in the queue? So I'm going to make it as KEDA demo, and my company is going to be blog. Demo I'll make it, and I'm going to create a new local app settings. This is where all my connection strings and everything would be saved. So ensure you don't commit this particular file into your source control. And this is the service bus what I have already in my Azure portal, in my Azure subscription. So I'm going to choose that, and this is the queue which is present inside that. So, and now for me to debug locally, we need to create a storage account in Azure. So I'm going to use one which is already existing. So with all these inputs, the Azure Functions extension should be able to create a new functions project for us. Yeah, so once it is created, as you can see in the left hand side under the functions window, that it's a local project. That means this is something which is present only in my local and is not really published into the Azure. These are the other two projects which are already published into Azure. So for this demo, we are not going to do any publishing to the Azure, but instead we will do everything in our local machine itself. So now let's explore the project structure a bit. So first thing is, this is the CS file where the function is created. The function name is service bus queue trigger C# KEDA demo, which is what we keyed in the entry. And this is the run method which gets executed as and when any message is arriving in this particular queue. So local settings JSON is where all your endpoint details would be available, and host would mention what kind of what are the different other settings is required for this Azure function. And I have .NET Core 3.1 in my machine, so that's why the target framework it has created with .NET Core 3.1. Right now, let us first execute the function to see how it works. So go to this run, and then click on this play button here, and it should start hosting the application in the Func tool. Let's just give it a minute for it to build, and then we should be able to see the function hosting this particular function. Yeah. So now the function is available and it's hosted listening at this particular path. So what I'm going to do is you can either use a service bus explorer to post a new message into it, or you can also write your own custom code to publish messages into service bus. So for what I have done is I've created a small C# project to just I've used the Azure Service Bus SDKs, and then I've created the project to push messages into the Service Bus queue. So we would also extend this later to see how we can simulate more load into this particular queue. So now I have just run like 5 threads, and it would have just run a couple of iterations. So as you could see in the logs here, for each and every message whatever we have written, so hello KEDA 143 and all these are the different messages which were posted by that particular application, and for each and every message our function got triggered. So that confirms that the function is primarily working good, right? So now we can stop the function, and we can move on to see how we can dockerize this particular Azure function. So again, to dockerize it also we could use Docker the func tool itself. So if you go to, just to ensure I'm in the right directory, yeah, so func has something called Docker. Func basically has a lot of other commands, and if you go and hit func you can see all the different commands what it has, but out of this what we are going to use is the func init. So while initializing, you can also initialize a new Azure function from the command line, but in this particular case we created using the Visual Studio Code. So what we would do is we'll just only add the appropriate Docker files, so that we should be able to create the Docker image for this particular function. So now this particular command would help me in creating a Docker file. So if you go back to Visual Studio Code, you should be able to see that there's a Docker file which is created. So it says it's going to be taking from 3.0. So most likely I might need to downgrade my function to 3.0 because this tool has created from 3.0. So I might not need to actually downgrade my application. Instead, I would ensure that this particular image is going to be pulled from .NET Core 3.1 SDK. So I'm going to make the change here, and then I'll save it, and I'm going to build the Docker image. So Docker build, the name could be Service Bus Queue Trigger KEDA demo video, and then I'll give the context as this particular folder. Oops. Okay, that's /t. Okay, all right. Yeah, so but basically the Docker image has been created now. So just to check that, what we could do is Docker images, and then I'm gonna say grep KEDA. So this is the recent one what we have built. These are the other KEDA related images what I have in my machine, right? So now to check how this image is going to work, right? So what we need to do is we need to run another command, which is here. So I'm telling the Docker to run my particular this is the image name what it needs to run, and what are the environment variables what I need to be passing to execute this particular image. So basically these are the ones where the service bus connection string is maintained, and also the logs for the debugging things are maintained there. So now the container is running. So again, let's use the same application to just pump in messages into the service bus. So I'm going to start that, and if I go back to my Visual Studio, it already started picking up these messages. So that means we could see that these functions, whatever is hosted under the Docker container, is running properly now. Alright, so I'm going to close this particular window, and I'm going to stop this container as well. So what we have achieved so far is that we kind of created the Azure function, debugged it locally, and then we deployed it into a Docker container, and we also checked that it is running properly from a Docker container. Right, so that completes this step 2 in our in the agenda. We also Dockerize it, and the next thing is for us to deploy into the Kubernetes cluster, and then let's get into how we can see KEDA is helping us. So to deploy it into the Kubernetes cluster, first thing what we need to do is we need to push this particular image, because this is what is currently residing in my local machine. So we need to push this image into the Docker hub. So for that, you need to, before doing that, you need to basically log into Docker. So in my case, I believe I should have been logged in already. Yeah, this is my credentials, like wannabe geek is my Docker repository name. So I should be able to use that and then push this into that. So for that, what I'm going to do is I'm going to first tag this particular repository. So I'll say Docker tag, this is my local name without the repository. So this I'm telling that wannabe geek /sbq trigger KEDA demo video, I'll name it. since we've just named it as a video here, make it as video latest. The tagging is complete. Then next thing what I need to do is I need to then push this particular image. So for that I would be using docker push one big this one's the video latest. So now this is trying to push into that. So once this is pushed, we should be able to again pull this particular image and then deploy it to the Kubernetes cluster. Let's give it a couple of minutes for it to push. Alright, the image has been pushed to the Docker. Now what we'll do next is to just go ahead and deploy this image into the Kubernetes cluster. So for that I'm going to run this particular command from func. So func has another thing called Kubernetes option command. So in that Kubernetes deploy, and we are telling the name of the deployment is func KEDA deploy, and the image name what we need to use is what is this whatever image we've just pushed in. So which is going to be func demo video latest, and then I'm going to do a dry run because just to see what is the YAML file it is going to create. Let's understand the YAML file and then we can we can deploy the into the Kubernetes cluster. So when I do that, it would create the YAML file. So this is where it is. Okay, it looks like it's given some error. Its name match. Okay, it just we need to give only lowercase letters. Okay, deploy. I'm gonna do this one, and I believe that should fix the issue. And yeah, so now what has happened is, so this has created the entire YAML file which has multiple parts to it. So one is the secrets part, which contains whatever my connection string which is available in my local settings.json file that has been base64 encoded, and then it's all present here now. That has been added as a secret. And then you also see something called the deployment, which is the actual Kubernetes deployment of our image. So here we have specified the image as one big /sbq trigger KEDA demo video latest. And what are the environment variables it is taking is Azure Functions job host. And third one, what is primary interest for us, which is the API version and the kind which is called the scaled object. So this is what KEDA is going to use, right? So before getting too much of details into it, let's go back and understand what KEDA is, right? So for us to get started with KEDA, the primary resource is to go to the KEDA website itself. So it's called keda.sh. So and if you go to the home, and then you will find out the details about KEDA. I mean the concepts overview. So what we are going to see now is this particular thing, right? So how this KEDA works. So typically with every Kubernetes there will be something like a metric server. So here this KEDA is going to be acting as a metric server. And in a typical case, what the metric server would capture is about the CPU and the memory usage of individual containers, and then depending on that the scaling would happen. But since we're talking about event driven stuff where a particular container or code would get executed on an event basis, right? You can't really measure or you can't really scale based on the CPU or your usage. So that's when we need to understand some of the external triggers, what would be needed to scale our particular scale our consumers. In this case, the Azure Functions, whatever we're running inside the Docker container, that needs to be scaled out as and when there are more messages available in the service bus, right? So that's where this KEDA is going to help us. So as you can see, so this is the component what you will get when you install the KEDA, and this listens for the external trigger source, and then it is going to it's going to increase the number of pods whatever we want. So technically you can go from 0 to any number depending on the scale length, whatever we want to specify, right? And how this works is it keeps polling on a specific interval to see what is the depth of the queue or the queue length basically, and then it will, depending on the queue length, it automatically sends signals for the horizontal autopod scaler to increase the number of pods in which our particular image is running, or in which our Azure function is running. right? So for this is what is used, it's called a scaled object. That's what is got created here, and here the name of the scaled object is func deploy, and it depends on the deployment name func deploy, so which is this particular deployment which is present above, and this deployment is nothing but is in deployment of this Azure Functions, right? And as you can also see in line number 48 here, so this is where it's telling that the type of this particular trigger is Azure Service Bus trigger, and from which service bus connection is coming from the Swami SB demo service bus, and this is available in my secrets here. And the queue name is going to be my queue name, and basically this is what the scaled object is, what is going to be used by KEDA to scale out the Azure Functions running in this particular Azure Functions available in this particular image. Right, so we need to add a couple of things into this. So basically the polling interval and there's something called cooldown period. So we will set both of them differently so that we'll be able to get the output faster in here, right? So I'm going to be adding those two settings under here. So which says the polling interval is going to be 10 seconds, and then the cooldown period is going to be 30 seconds, right? So polling interval is nothing but within how much of interval it needs to keep on polling for the trigger, right? That's what the polling interval means, and the moment and how much time it needs to wait before the horizontal pod autoscaler brings down the pods to 0 is where this cooldown period comes into picture. So it polls for every 10 seconds, and then the moment it scales up, and then it will wait for 30 seconds before it completely tears down all the pods and bring it down to 0, right? So I'm going to save this file, and we would now use the kubectl command to just deploy this particular file there. So the file name is funcdeploy.yaml. So I'm going to do that apply, and as we can see, it created the secret, and then it has created the deployment, and it also created the scaled object, right? So that's how we kind of deployed the Azure function into the Kubernetes cluster which is running in my machine. So now I'm going to get back to this window which is running on a WSL. So what I'm going to do is I'm going to use a watch here to just run through the command on a specific frequency. So get pods. If I do, there are no resources found because there is nothing which is running as of now. So as you can see, this is going to run the same command for every 2 seconds. So you can see the counter getting incremented here. So now what we will do next is let's go ahead and start pushing messages into the service bus, right? So for this demo, to see how the pods are going to increment, I'm going to say the thread count is 10, and I'm going to run this for maybe like 5 iterations to start with, right? And then I'm going to run this application, and if you go and look at this, ideally as we start pushing more messages into the service bus, we should start seeing that a new pods are going to be created. So it takes about minimum 10 seconds or more. Alright, ideally this should have come up now. Okay, so one thing what I missed to mention in the scaled object is about the queue length, right? So what is the queue length that needs to be watched for the KEDA, so that it understands that the queue is getting filled up, and then it needs to start spinning up new pods, right? So I'm going to mention that now, and then I'm going to again deploy this particular kubectl apply this file. As you can see, this is changed, and then this has been configured now. So now let's go back to have this here, and then let's run my messages thing to see if KEDA is getting into action. We start pumping in more messages now. We should start seeing after 10 seconds or so that it starts creating new containers and everything. Oops. Okay. Something is slowed down. It should start creating new pods. Okay, let's just give it one more chance, one more try. let me increase the iteration count to 10. So it's not right. Okay, yeah, there you go. Yeah, so looks like there was a bit of a lag. So it says now container is creating, and then the container started running, and it will also wait for some more time. As the container is running, we'll start pushing more messages. Maybe I'll run this once again to see if it's able to pick up the messages as well. It should keep running for some more time. Yeah, it again started creating new messages. Maybe I will increase the thread count to more, like 50 threads, and let's do some more load to see how that behaves. So I'm gonna run this. So I've given a 2-second wait here in my application just to simulate that, yeah, at every 2 seconds interval or so we keep pushing in more messages. Yeah, the more messages are getting pumped into the service bus, and yeah, it's creating new pods, and then it keeps running, and once the load is done, it is also tearing down the entire all the pods and bring it down to 0. So you can also just run through a Docker command to see how many images are running. So as you can see here, so 1ab // blah blah blah, this is what is running now, and once it gets terminated here, the next terminator in the Docker PS, it should just go off from there too. Yeah, it's already done. We have only see the KEDA metrics adapter and the KEDA thing which is running here. So yeah, so that's how we could use KEDA to basically auto scale our pods, either scaling it up or scaling it down. Both are possible depending on the queue depth. Yeah, so if you take a look at the KEDA website, we can understand more on the built-in scalars what are available. In this particular example, we've used the Azure Functions support, but as you can see down in the scalar section, there are more support available for AWS CloudWatch or Apache Kafka, or even in Azure for that matter. You can also connect it to event hubs and different other things. It also has support for Google Cloud Platform and everything, right? So basically it's not really tied close to Azure or anything. It's more of an open source project which covers across all the clouds, and it's basically like cloud agnostic, and wherever you run Kubernetes you can implement KEDA, and then you can have these things going. If you want to take a look at the project of the actual source code of how the KEDA is implemented, you can go ahead and take a look at this particular thing, like github.com/KEDA core/KEDA. So that's the project's implementation. And if you want to install KEDA, you also have options to directly install from here, which is what I kind of did it. I cloned this particular code base and then ran these 3 commands here to deploy KEDA in my local machine, right? And the other thing which I wanted to call out is the service bus message generator application, which I've used in the sample to load the service bus with messages. So that's also available in GitHub under my repository. Yeah, so it's github.com/svswaminathan/service bus message generator is the one. Yeah, so that's pretty much what I wanted to discuss in here. I hope you liked it. Thank you.